Hello everybody and welcome. Here we're gonna prove the D-graph model for the two solution, the linear solution and the root solution, non-linear solution and linear solution. So you should know that we have a three-step mechanism. Oxygen diffused through the gas to the top of the wafer, oxygen diffused through the oxide that has formed on the wafer to the silicon interface. Oxygen reacts with silicon to form silicon dioxide. Limitation of this model, that is a 1D model, not accurate for heavily doped silicon, not accurate for thin oxide, less than 2 to 25 nanometer. So you should know that we have flux, gas flux from imaginary surface, what we call the concentration of gas here as a Cj, will diffuse through the silicon dioxide interface, and we will have also flux from through the silicon dioxide, and we have actually also flux through silicon dioxide. We would call it G3. You should know this situations and the limitation of the metals, that it's not used for all the situations. You should know this. You should know this is very important. You should read it. You should pause the video and read it, please. Okay. You also should read this parameter carefully, because we will solve a mathematician, so we will not explain all this. So please just pause the video and read it carefully. Okay. Studying the flux of the gases, we start first from fixed first law. We start from the G1, the flux from the imaginary surface, what we call Cj, to Cs, the outside of silicon dioxide. Now, here you can some book read this part and some book don't. They just say this equal Hj directly. If you I just write it to inform that we have this some book write this part, so if you want to read about it, you can search about it and read it. So we'll start here from that Hj. If you read back, that it's called the mass transfer coefficient, and Cj is the bulk reactant concentration, and the Cs is the surface gas concentration. So just we call this equation flux G1. Okay, then we use Henry law. We will use both this equation and put it inside G1. Solve for Cj and solve for Cs. We just divide over HKT, this part will gone, and we will have that Cs will C naught over HKT. The same for this part, we just divide. This part will gone and will be Cj over C star over HKT. Now just take Cg and Cs and put it here. and the equation will be like this. Now take HKT, both of them outside. We will form like this. So we call this part H. H. It's for symbolization. Now we will have that the flux G1 is equal HC star minus C2 C naught. Now we will start from diffusion 2. Same for diffusion 2, we write it like this. And for diffusion 3, situation 3. Now we will study that at equilibrium. We just say that G1 equal G2 equal G3. All of them, they equal the solution GSS. Now we put that the G3 is equal G2. We put here G3 is equal G2. Look here for G3 and look here for G2. Okay. Here we just make the D inside, and we divide. We multiply by TOX. So we'll gone. It will be in the right hand side. No need this, for we have already done it here. So it will be like this. Now we want the CI to be in the right hand side. We just take by DCI. So this part will gone and it will be here. Now just divide by D. We divide this part by D and this part by D. D here will be gone. Here D will be gone. And we will have this part will be multiplied over D. Plus CA equals C naught. Oh. Now take CI outside, both of them, and we will have this solution in this way. Okay, now here we just divide this part. We put it over here. So here it will be gone, and we will be here have KS TOX over D plus 1, and it will be solution in this way. With just a few steps. Okay, this is what we have done. Now we will solve for, here we'll solve for G3 equal G2. Now we will solve here for G3 equal G1. We put equation G3 equal G1. Okay, he will put H inside. We put here H inside. And here we bring CI here. Just a moment, I will show you. This is the CI. Okay, we just put it here in the G3. Okay, and it will be this. Now here we multiply. In this part we multiply by this part, so it will be gone from here and will be in this in the left hand side for HC star, multiply by H star and multiply by HC naught. Now take this part by the plus, just a few. take this part by plus, it will be over there, and this part will be gone. Like it's here. Okay, plus HC star. Okay, we have the solution, and now yeah, here we take C naught outside, as you see here and here, and we put here H multiplied inside here, the bracket. It will be HKST over H. Okay. Now just solve for C naught and divide over this part. So this part will be this part, okay, over this part. Just divide, a normal divide. This part divide on themselves, so it will be gone from the right hand side. It will be in the left hand side here. Okay, and this solution will be like this, and we call this equation 5. Now use equation 5, this equation, in equation 4. Where is equation 4? This equation. We will put our solution C naught here, and we will have this solution. This part will gone, this part will gone. Now multiply 1 over H. H here will be gone. Ks over H will be, this will multiply by H. This H will be not exist, so it will be the normal this situation, and here will be just left for 1. You should know that C star is Henry coefficient in the Pj. What is Pj? If you back, it will be the partial pressure. Yeah, Henry. It is Henry gas law constant in partial pressure. So we just put what C star equal here. It will be a form like this, and we will call it equation 6. Now we will study cases that if these when we put d equals 0, the solution of Ci will be 0, and we will put d infinity, the Ci will be equal C naught. We will see that. So when we back to the Ci equation, where is Ci? This is Ci. Okay, we will put 0. Okay, we will put in d here 0. So this part will be equal to infinity, and this constants equal over infinity will be equal to 0. Okay, this is case 1. This is the guys, the linear case. Okay, I will show you. Just a moment. Now the case 2, which is d equal infinity, we will back here d to put d the same. This d will put, and the case 1 we put is equal to 0. Now we put it we put d equal infinity. Okay, now we back to put that d is equal infinity. So we know that every 1 over infinity is 0. But you should be careful that here that we start from solving from equation C naught. We don't use C here, the equation Ci. This is Ci. Okay, this is Ci. Actually, if you solve for Ci or for C naught, you will have same solution. Okay, I will show you now. Here here I just start from C naught. Just if we back to equation C naught, this equation, you will see that we have 2d here, d, and here d. just put infinity on it. Okay, okay, now this part will be equal to 0 and this part equal to 0. So what we have left for here, that h c star ks plus h. Now multiply 1 uh, 1 over h, and we will have that here h now exists, so it will be ks over h plus 1. You can put c star, which is equal this magnitude, this h multiplied by pj, or you can just write it like this. It's okay. Now we will pack just for ci. Okay, this is the ci. Same way, put t equal infinity. Put t equal infinity. If you put t equal infinity, this part will be 1 over infinity. Anything over infinity will be 0. So this part will be 0. This is what left. Okay, if you look carefully, here we solve for ci. Okay, and here we solve for c naught. What you see here, that actually this the ci become equal c naught. This is this solution actually for c naught, and this solution is for ci. Both of them are equal. This is what we have written here. Okay, okay. Now we left for the flux 3, that G3 is equal KSCI equal to GSS. We just give CI, the equation CI